Joining the best room at Jfokus C4, and up next is Leander.
Thanks for the good intro. Thanks for joining this almost last session. There's only one left then after mine. I want to talk about software quality assurance. In the Kubernetes world, software quality assurance and its challenges when it comes to microservices.
Leander.
Hard, but of course we can do. No, don't worry. So we do that. I have two hands, all good. I think you understood me so far, right? So, quality in a square. I have brought quite a big demo, a few slides, and we talk about a framework called Testkube, which I think revolutionizes the way, where, and when we run our tests for our microservices and for our systems. Now let's go back in time a little. In that time here, anyone know the movie? 2001: Space Odyssey, right? And what's that thing in the middle there? Yes, thank you. You're the best. That's our good old monolith. And you know who the guy up there at the right is? What's that called? That was the early code monkey, right? So I know there's a lot of ranting about monoliths, right? We kind of all love them, and then we, for some reason, started to hate them. Have you seen this good early morning session with Nace Shutter on about, monolithic systems? You shouldn't start with microservices if you didn't do the monolith right and all that. There were quite a few things that weren't so bad about monoliths. Testing, for example. Testing was rather easy. You didn't have any distribution, you had no inter-process communication. The technology stack was usually pretty simple, right? You had good old Java EE 5, 6, something deployed in some huge, humongous glassfish server. So you had low infrastructure complexity, and the best thing about the infrastructure was you didn't have to take care of it because it was some other team, right? We threw stuff over the wall, and then they deployed the stuff. We usually had long release cycles, meaning also we had long test cycles, like, yeah, we tested a month's time, then we're finished, usually one team. So the complexity of handling monoliths, assuming we had a well-structured monolith that was only monolithically deployed, so testing that one wasn't that hard. Now, for microservices, that changed, right? The situation changed. Microservice-based systems are complex. Yeah, don't tell me anything else. I've been developing those for the last, 5, 6 years with a huge team. And testing them holistically is even more complex because you have this high distribution. You have, various communication channels and mediums. You have GraphQL, gRPC, REST, maybe a few message queues in there. You have the databases. You have all those deployments units. If you go totally crazy, you probably have a very, heterogeneous technology stack. Kotlin, Java, maybe a few Go services. You have different database units running around. So the infrastructure complexity with those many components in a full DevOps mode, you also had to take care of suddenly, right? New operational model and more responsibilities for us developers, and usually the release cycles are very, very short. You have many teams, you have to coordinate. So testing became quite challenging. You may ask, who's this guy up there to talk about? So this is me, Leander. As you see, I come from the very, very southern part of Germany, small town called Rosenheim. Our headquarters in Munich. So Austria is not far. So you see the Alps at the very bottom, the green Alps, because we don't have any snow right now. There should be, but there isn't. So this is where I live. I'm now managing director and CTO, working for a company called QAware. We're kind of an independent software project house. And the project I kind of talk about a little is a huge project, 80 DevOps engineers, 80 platform engineers, software engineers. I've been responsible for working for that large car manufacturer in Munich, okay, the one with the 3 letters. And we went this whole journey, from monolithic systems towards microservices, and then we realized, oh God, testing is something different now. We need to do something different. All right. Anyone read this book here, Accelerate? Yeah, a few hands. If not, it's not a big book. I think it's definitely worth the read. It's about building and scaling high-performing technology organizations. Now, management summary of this book is the following. They write about, developing towards a DevOps organization. They talk about, continuous delivery all the time. And you might ask yourself, why do we want continuous delivery? Well, those are kind of the benefits. You want low-risk releases, right? No big bang monolithic releases where you had on a Saturday and Sunday several hours, you developed for 3 weeks, and then you had this big bang release, and then all of a sudden you realized, oh my God, it's not going to work, we have to roll back everything. So with low-risk releases, you usually have happier teams, because no one of us likes to get up on Saturday and Sunday to do the deployment, right? Everything should be automatically. So we as developers, we're happy. Guess what? Happy developers produce better code, right? That is proven. Better code means better products, means happier end users, also really good. That is what our end users and obviously our product owners like, right? Happy end users pay nice money for digital products. Less rework also means lower costs and happy teams again, and fast time to market. I think in 2023, in a digital world, is also a key feature that we want. Now, unfortunately, all those parts there, all those benefits, as usual, they don't come for free. So I have to do all that here. Loosely coupled architectures. There they are, our microservices. Okay, so we have to change the way we develop software. We build systems, smaller individual parts, loosely coupled. Maintainable code is still an issue. Okay, maintainability, I think I'm definitely convinced is even in 2023 a thing. I know that there are teams outside that say like, well, yeah, we're doing microservices now. Maintainability is not so important anymore because if we fuck up, we can rewrite everything. Well, in my business at least, and I've talked to many product owners, they don't like to spend the same money on, getting the same again, or more money on getting the same, okay? So it's about investment. So maintainable code is important. You want empowered teams. You have the teams that make their own architectural decisions and their own design decisions. Security should not be taken lightly, right? So security from day one, when you start with the first concepts, with the first ideas, you should already start to think about security as well. We need test automation, and test automation also comes with continuous integration, right? We need that, we always did that, so that shouldn't be something new. Maybe something new from some teams is this whole GitOps thing, okay? So you have the state of your environments stored in some Git repository, and you have some GitOps tool, be it Flux or Argo, that runs on your cluster, and that kind of, scans and checks the current state from the desired state based on this Git repository, and then automatically does the deployment. So no developer should actually manually do a deployment anymore in 2023. So this is what GitOps is for, so you have this deployment automation. And for having always the visibility of the current state, what you need is then monitoring of the whole system, of your whole distributed system, plus the automatic alerting once things go wrong, and things will go wrong in a distributed system. So I see this perfect world complete world of continuous delivery is not so easy to achieve. It means a lot of work for us engineers. Now, I am a part-time teacher at a university for software quality assurance, and to be honest, this is one slide from my slide deck I show to the students. There is actually an ISO norm. This is pretty old already. The ISO 2510. Anyone knows that one? No hands here. So there's one hand. Thank you, the unicorn. Yeah. So I think it's 11 years old. They just revised it last year, November. So they made a few changes. You don't have to stick to it, but what I will show you now is all those quality attributes. And if you want to take it seriously, and I think we should, then this means, again, a lot of work. So what do you have? Good old security, right? So the first ILITI, right? You need to take care of, encryption, at rest, in transit, authentication, authorization, OpenID Connect. And if you want to be sure that you didn't mess up with all the security code and all your security infrastructure, well, guess what? You probably have to write some tests. You have to write some penetration tests. You have to do penetration testing. You have to scan your library dependencies for known vulnerabilities for all those CVEs that you don't want in your product. So security is, if you take that serious, you need to test in its work. Functional suitability, strange name, right? This is about our acceptance criteria. This is about, did we build the right software? our end users want, our product owners want. Is it complete? Is it correct? Is it appropriate for the use case? What do you have to do here? Well, good old acceptance testing. Maybe you have a few cucumber tests or something like that. To, a bit of UI automation, usually do acceptance test via UI automation, or maybe you do acceptance test on your REST APIs. That's also possible, but again, you have to write tests and you have to run them continuously. Usability. Well, this one is hard to automate, but in all fairness, this is part of the ISO norm, right? This is about, learnability, accessibility. Does it look nice? Does it appeal to the end users? So this is usually performed manually. So luck here, we don't have, we have to do it, but we can't do it automatically, unfortunately. Efficiency, time behavior, resource utilization, capacity. Yes, I know we're in the cloud, and technically we are, we can scale indefinitely, but that's kind of the theory. I think it's still, it's still important to look at your systems, look at the time behavior. Can I do like, I don't know, 350 requests per second and answer in, I don't know, under 500 milliseconds? So if I have those hard KPIs, those hard SLOs and SLIs, then guess what? We have to write performance tests, load tests, Gatling, K6, you name it, all those load test tools available. Reliability also doesn't come for free. Recoverability, fault tolerance, right? We did microservices because we want fault tolerance. Well, availability. Is my system available if things go down? Well, we're in the chaos testing world here. If you really want to be sure that your system doesn't fall over, if you still serve your users, if certain parts are not running anymore, you have to test for it. Otherwise, you don't know. Good old maintainability. This is where we're usually good, right? Modularity, testability, modifiability. This is good old static code analysis. You have your Sonar server, running there, checking your source code. Maybe you have a few Arch unit tests that kind of run and tell you that your modular structure is still okay, or your layered model or your hexagonal architecture, onion architecture, whatever you chose, okay? If you want to be sure that your architecture is still in a good state, in a good shape, then you have to test for maintainability also. Compatibility, and last but not least, there's portability. Well, maybe not so important, but on a compatibility level, let's say, the interoperability. Think about microservices. You have one service or two services communicating with each other. How do you know that the interface change you just did on the downstream REST service, that this doesn't break the upstream service? If you want to be sure, contract-driven testing is probably the answer, right? Portability similarly. Now, I said before, this ISO norm is pretty old already. There are quite a few entities missing, in my opinion. I brought a few. Pretty new now is safety. So is this product safe to use? It's sometimes not so important for, for enterprise software, but safety is a feature that has been added to the latest revision of that ISO norm. And others are missing. Deployability, for example, right? Is this whole infrastructure code I have for my technical infrastructure, my infrastructure as code, is that really in a good state? I need to check that as well and test that as well continuously. Operability, are my monitors in place? Is my logging properly? Do I expose a metrics endpoint? So is that from an operability standpoint of view, are those quality attributes met? So you see, this is a lot of work, and I think we need to care for. Yep. I know, and it should be, this is a kind of the same word. I think from a usability point of view, operability means that you can kind of use it properly, right? And the operability I'm talking about is more like the low-level ops part, okay? Ops operability. Maybe we should choose a different meaning. And that's maybe the big issue on the ISO norm, that those terms are not nicely defined, right? There are different approaches now to defining software quality. You may have a look at the, what is it called, the ARC42 guys. They have now released something called Q42, so Quality 42. They take a bit of a different approach. And you're right. I mean, operability, there is loads of different forms of operability. The technical operability, so can it be operated on a Kubernetes cluster? And then there's this operability from a user perspective, like can I use this stuff, right? Well, ask the ISO norm. Oh, yeah. Yeah, so this is actually the wording of the official ISO norm, right? And if you want to spend the 150, what's the currency in Switzerland? Well, Swiss something, Franken, Swiss Franken, it's 150 Franken you have to pay, and then you get a huge piece of paper or a PDF in those days, and then you can read that. And that is exactly the problem. But I only want to point out that there are quite a few attributes that you want in modern systems, right? Security, you cannot argue away. Functional suitability is a must. Maintainability is a must. You have to talk about reliability and efficiency. You will not get around this. So you should test, and that means a lot of work. Now, what did we do in those good old times? Well, we had our Jenkins or some CI tool, right? And we had this one pipeline. And then all of these tests, what did we do? We stuck them all into this one humongous monolithic CI pipeline. Unfortunately, we always called this CI/CD pipeline because this pipeline ended up doing more and more and more and more than it actually shouldn't do. Of course, you check in your stuff, then this server starts to build. It starts to, execute maybe your unit tests or early tests. Maybe does some, quality performance, quality checks using Sonar and static code analysis. That's part of that phase. Then you do the integration, whatever that means. Usually you build a Docker image, you push the Docker image to some registry. Then maybe you have some, some magic that calls some API endpoints of your Kubernetes or your OpenShift cluster to tell them, hey, I've built a new image, please deploy that microservice here. Once you have that deployed to some integration environment, then you have a final running system, and then it's worth to then finally run acceptance tests, performance tests, security tests, and any of those other tests. Unfortunately, that makes maintaining those pipelines very hard because they get bigger and bigger and bigger. You need quite a big CI infrastructure to run all those tests continuously. I mean, think about many teams. These pipelines will run forever, right? Because acceptance testing isn't going so quickly, right? This maybe run 5 minutes. Performance testing, similar, half an hour test, hour test, security. And obviously I'm exaggerating here, but obviously it could paralyze things, right? So it could be smart, so putting even more smartness into those pipelines. Next thing is, for that to work here, well, you need external access to your cluster to be able to deploy something and to test something in your cluster. I don't know about you, but not all of the microservices we build, they're even accessible from the outside of the cluster, right? So you usually have some API gateway that is accessible from the outside of the cluster, but the rest of those microservices, they live quietly inside the cluster. So what can I do to test these? Should I expose them? Well, that wouldn't be such a good thing in an integration environment because in production, I don't want to expose them. So are you testing the real thing? So that's an issue. Pipelines, well, they only run, and that means the tests only run if things changed, right? But what if in a microservice architecture, you have one service and a downstream service? The downstream service changed, well, then I would have to run the upstream test of the calling microservice. But that doesn't happen, right? Because it's two different pipelines. So there are quite a few serious drawbacks, in my opinion, and the biggest one is delayed feedback in long release cycles. If we do not stop to put more and more and more into those pipelines. And the first problem is already the name CI/CD pipeline, okay? That should be at least 2 pipelines, because CI is something different to CD, okay? Continuous integration and continuous deployment are 2 different things. So please stop putting those 2 things into one, right? In software engineering, we wouldn't do that. Separation of concerns, right? We all know that in plain software engineering, and I think we should apply the same principles here when it comes to how we test and deploy our stuff. Now, I know this is German. I don't know, can Swedish people read German? I didn't translate this, but if you don't trust me, okay, but trust me, I'm an engineer, okay, you look at my t-shirt. If you don't trust me, then please trust Yoda. I tried to translate it. Let's see if they have the translation for that. Let's see if Google, so the translation from that should be that. Du kan göra det, men det suger That should, okay? So that should be the translation of the stuff I just showed. Anyway, okay? So either trust me or Yoda, we have to change something. Now, the one thing I just mentioned is the following problem that is special to microservices, okay? So this is a synthetic example, okay? You have 3 microservices, A, B, and C, and you have 3 teams. Each one of the teams is responsible for one of those microservices. And then to make things even more complicated, you have some external systems by some other teams you don't really know. You only know that these services exist, and you kind of have a dependency on those. Usually some SOAP services lingering around, in this enterprise you're working for, some strange backend systems, some old legacy, vintage, whatever systems. Now with the so this is really hard, okay? And with the pipeline approach, as I said, now I want to be sure that microservice A is still functioning, even though microservice B and microservice C changed, right? With the pipeline approach, the test for microservice A wouldn't run. Now you could say, yeah, well, we're all in the same company, right? Come on, dear team B, team C, give us a ping so that we can, manually trigger the tests. But as you know, we're all in an agile world. We're all in this, in this crazy spinning wheel. Every 2 weeks there's release. We're always in stress. So people tend to forget to tell us that something changed and that we should maybe run our test suites. And even worse, with those external systems that usually only change, 2-3 times a year, they will definitely forget about us. They will probably have a lot of more consumers they would have to ping. So if they break or if they produce or introduce an incompatible change, I will, I don't know when, hopefully not in production, realize that the backend system just changed incompatibly. So I want to know earlier. So now I had this idea, okay, if not the pipeline, when should those tests run? And then I came up with this, crazy or not crazy, whatever idea. I said well, I have loads of infrastructure there. I have this huge integration environment that's lingering around most of the time. That's usually only deployed a few microservices. I have huge hardware there. Why can't I use this cluster and the hardware and the resources I have there for something good? Why can't I just let those tests run? So the first idea was let them run continuously. Let this load test run every 5 minutes. Why not? Cron triggered, right? Or even better, not cron triggered, let the tests let them trigger and let them run whenever something in the cluster changes. So it's not some pipeline from the outside that says, you have to run, we have to run. The tests or some magic knows itself, hey, deployment microservice A changed, I have to execute the following tests. Or deployment microservice B changed, I have to execute the following tests. So having some kind of an event-driven testing approach. So my dream, I'm in the business for 30 years now, is still this perfect product assembly line, digital product assembly line. I don't know if anyone have ever been in one of these car factories. I had the honor to see one at BMW. Okay, everything's automated. You have all those robots, and they, put everything together. Why do they do that? Well, continuously, reliably, always producing the same quality, producing the same output. Automation in our engineering terms. So here are a few core principles I think that are important for such an assembly line. The first thing is separation of concerns. I already told you. You should do one thing and you should do that one thing well, okay? Don't mess up with the phases. Build, CI, deploy, end-to-end testing, this is different things. So be careful to stick all of these into one big pipeline. I think this would violate the separation of concerns principle. Choreography over orchestration. Kind of heard that from a microservice context, right? Either you have that one thing that orchestrates everything, now you, now you, now you, now you, or you have this like in a ballet, right? It's more choreographed and it's more event driven, okay? So we don't have any codified downstream dependencies in the pipelines. Loose coupling, okay? The test suites and the tests should not need any knowledge about the components and the environments they run in. And it should be more event-driven, time-based, commit-based, deployment-based, release-based. So based on those events, timely events, you should run the correct tests. I think what we do in production should also apply for our tests. So why not apply the GitOps principle to our tests also, right? So how do you deploy your test definitions towards the cluster? Why should that be any different to the deployment of your microservices themselves, okay? So assuming you could express your tests in some form of Kubernetes YAML, some manifests, then it would be exactly the same as your microservices. You have one consistent approach to how the cluster is changed, and you have one consistent view of what is running on the cluster and what is running when. And the holy grail towards holistic quality is all those test results, failure here, failure there, all the metrics that these tests produce, ideally, they should all be ingested into one single source of truth, so that in the end, I can always say, hey, my system is green, my system is ready to deploy, or the following components are ready to deploy, those two not. So I have kind of this cockpit of, right? So I have kind of a quality cockpit. So before I start with the demo, here's what it can look, or what I think it should look. So nothing new here, okay? You have some developer, happy developer, pushing his code towards some CI system, GitHub Actions if you like, or a Jenkins. So what does that do? It checks out, it performs the build, maybe a Maven build, maybe a Gradle build. You do some testing, JUnit, TestNG, early integration test using test containers if you like. You have maybe a SonarQube analysis there, so the early static analysis of your code, so you know about the maintainability early. And once everything's pretty smooth and green, then you build an image and that's done, okay? CI part or the build part, done. Next thing is you push the image to some image repository. Also pretty easy. GitHub packages, Amazon ECR, Nexus repository, whatever you have in the company. Then the magic deployment part comes. So quick question here. Who's the Argo CD fraction? Flux? Okay, so it's a 4-2, unfortunate. Now, I'm a big Flux fan, but I don't have anything against Argo either. Both do the same job, basically. What do they do? Well, first up, they watch for changes on the manifests in a GitOps repository. So if I change a config map, a config variable, the image ID, or whatever I change towards my microservice deployment, your GitOps tool will notice, and your GitOps tool will take care that those changes are deployed onto your cluster, okay? So no outside intervention with your cluster anymore. And in highly regulated environments where you definitely will not get access via kubectl and the kube API server, you definitely have to go down the GitOps road. What these tools can also do is they can watch for image changes on the repository, right? So if either the definition in the GitOps repo change or the image changes in the repository, those tools will notice and they will deploy that stuff towards your cluster. So now you have that perfectly always up-to-date integration environment. And now comes the funny bit. Now I want to trigger something. I want to trigger the tests, okay? And this is now where this framework Testkube that I will show you in a minute comes into play, okay? So Testkube is, well, it's a cloud-native component. It's a small infrastructure component, a small open source component that also runs in your cluster. And Testkube is then triggered either by your GitOps tool once the deployment is finished. That's one option. Or what it can also do is it can basically listen for change events on the cluster itself, deployment changed, config map changed, service changed, ingress changed, whatever changed, and then run the desired amount of tests, test suites, Cucumber tests, K6 load tests, acceptance tests, yeah, security tests. And this is basically Testkube, okay? So Testkube is this, cloud native testing framework for Kubernetes. It's all open source. If you ask yourself, am I somehow associated with them? No, I'm not, right? I'm kind of an open source contributor to the project, yes, but I'm not really part of the core team. But that doesn't matter, right? A few months ago, I found that project and I thought like, whoa, this is exactly what I was always looking for, okay? So what does it allow? It allows to express your tests as, well, the standard Kubernetes YAML style, okay? So you define your tests, what type of test it is and when should it run and the parameters for the test. You define that using a good old Kubernetes manifests, right? those Kubernetes manifests. As I said before, you can also GitOps manage using your GitOps tool, be it Flux or Argo, and then your tests are deployed and also up to date on your cluster. Now what they have is, well, they have a concept called the executor, and the executor is actually the smart logic that knows how to execute a K6 test, that knows how to execute a Gradle-based integration test, that knows how to execute a Postman REST acceptance test, for example, okay? So it makes it really easy to run all those different kinds of tests. It has a nice UI, so it's good for all the tester teams if you have, but it's really developer friendly. And I think the best thing is it takes out those test orchestration and test execution, it just pulls it out of the pipelines and puts the smartness into your cluster. So, quick look at the demo architecture. Well, I actually have 2 demos, but let's see where we are with the time. Oh, 20 minutes left, that's awesome. Now, this is what your cluster at the moment looks like, or I have prepared 2 clusters. One is running in the Google Cloud, one is running locally on my machine. So the good thing is you can run Testkube locally on your machine. Either you have Docker Desktop, Rancher Desktop, Minikube, you name it. You could install Testkube also on your local cluster. So you have this optimal dev prop parity, right? The tests that run on your cluster can also run on your machine before you do the first commit, okay? Now, Testkube comes with a few components. So you have this dashboard there, okay? I personally don't need UIs, but you know, some test expert or your product owner or whoever, they like to have fancy dashboards, fancy UIs to see, hey, what tests have been run, what's the current status. You can trigger the test manually using the UI for some experimental testing. So all possible here. Then Testkube provides a CLI. The CLI comes as part of the kubectl plugin. So I always have to say kubectl, Testkube, run test or something, okay? This CLI talks to something called the Testkube API server. So all the smartness is in there. Then, well, there's MongoDB and NATS. I mean, this is not really important. This is basically storing all the test results and kind of for internal communication. So this is not usually something we interoperate with as developers or testers. Testkube comes with a number of so-called CRDs. I don't know if this term is, this is custom resource definitions, okay? So this is a declarative way to extend Kubernetes with new resources. Now the main resources is test source, test suite, and test triggers. So test source is pretty simple. It's probably a Git repository. It's probably the Git repository your microservice lives in, right? Because the test for that microservice, well, they're probably part of exactly the same repository. Then you have tests. Load test, K6 load test, Postman test, artillery test, Cypress test, whatever. Those tests can reference the test source because the tests need to know, hey, where are my test files? Then test suites, guess what? Not something new. Test suites is a simple aggregation of individual tests, right? Run that test, then sleep for 10 seconds, then run that test. If that test failed, then continue, or if that test failed, then run the next test. So you have some conditional logic possibility inside the test suite. And the test triggers is now then the 4th missing part. With the test trigger, I can say whenever something changes in the cluster, when a deployment with the name A in my namespace default changed or is created or is deleted, right? Kubernetes is a simple state machine. You can do 3 things. You can add something, you can modify something, you can delete something. Then please run the following test suite. So that's the test triggers. And the executors down there, they take over. These are basically plain Kubernetes jobs, right? They're executed as Kubernetes jobs. So containerized tests that then know how to execute the performance test. From outside, you can trigger webhooks. So if you are kind of more of the old style, you could technically trigger from your CI pipeline, to run tests. You can connect it with monitoring systems like Prometheus to get metrics about all the test runs, right? And all those tests, they then go towards my, my Spring Boot deployment or my Nginx deployment or whatever I have there as a workload in my namespaces. Okay, then I think it's demo time. Oh, demo-wise, that's going to be difficult, typing with 2 hands and holding a microphone. Can I have a helping hand? Yes. Oh, that's awesome. Thank you. All right. So if you want to follow along afterwards, then, clone this repo is all MIT. Feel free to copy and paste whatever you like. Now, right now, is that big enough for all of you? Can you see that? Right now, I'm locally, like that. So I'm at the moment on my Rancher desktop, so this is a local machine. I have my microservice deployed on my local machine. Now, if you want to initialize or install Testkube locally, well, you have to download the CLI. As I said, that's a kubectl plugin. You say kubectl testkube init, and then it will initialize. Under the hood, it's basically a Helm install, okay? So this is a Helm package that's going to be installed locally. Yeah, for the sake of time, obviously, I already did that. Here is my Testkube namespace. It comes with a nice dashboard, told you before. So this is pretty much what the Testkube, what the dashboard looks like. This is, for example, a scheduled postman test that runs every 5 minutes. Okay, so that's a simple example. This is what the UI looks like. Here you have the results and the output of the test run. And technically, basically you could, or your test team, if you have a separate test team, you could let them access this UI and create test suites from tests if you like. Here are the executors. This is where I define triggers. And down here, this is where I define test sources, like my Git repository. Okay, nice, simple UI. Now going back, if I want to interoperate, then, well, I basically can do two things. I can do that here, create test. I say this is the following file. So in case of a Postman test, I need a so-called Postman collection I can create using the Postman UI, for example. I give it a type. This tells Testkube, hey, please use the following executor to execute that, the matching executor, and I give it a name, okay? So I have created that one. And now, guess what? I can let that run. And then what I could do, I could watch that run. Let's see if that's working. So you see here, this test already ran. It's already finished, done. So this is how you run your Postman tests from inside the cluster. As you see here, if you want the scheduled one, you can specify, a schedule parameter as well with a Velotronics expression, and then that test would continuously run every 5 minutes, or maybe your security test or whatever. Well, yes.
So you need to have those executors. Can you write your own, or does it exist for many different kinds of testing?
Okay, well, good question. I mean, we can kind of interact, of course. Yes, well, there are a certain pre-configured executors. In the end, an executor is nothing else than a container that needs to adhere to a specific contract, let's say. Right? It needs to have a specified entry point, for example. And when I started with Testkube, there was no support for Maven, there was no support for Gradle, there was no support for K6, there was no support for Karate framework, there was no support for the ZEP security test framework, and I contributed all of those executors. So yes, it's like 1 to 2 days of work to write your own executor for, let's say, a test framework that it doesn't support yet. And I can tell you the community, the Testkube community, will give you super support if you have questions or anything, right? So yes, so if there's something missing yet, then feel free to contribute one. I show you executors. Executors. So this is the executors that are currently installed. JMeter, Ginkgo. Anyone know Ginkgo? I think it's from the Go world. It's a framework from Go. Maven, Gradle, SoapUI, K6, Cypress, curl, Postman, Artillery. And anything else can be added, as I said, with limited amount of work, 1 to 2 days. Now, from the examples you see, creating those tests is really simple if you want to interact locally with your Kubernetes cluster. So you always say, Testkube, create test. You give it the test files you want, and that's it. Is your arm still okay? Yes,
Yeah,
it's getting a bit.
fine.
It's getting a bit
I felt
tired.
like I was
Yes.
in your way.
No.
Okay.
Not
Are
that
you sure this isn't in your way?
Yes.
Okay.
Okay, so K6 load testing can be created really easily. Now, as you see here, the default is, or the easy part is, that you use the ---- file parameter. I mean, that's kind of easy for tests that only require one single file. But what if you have kind of rest assured Java tests, integration tests that use the rest assured framework? So only the Java file wouldn't be enough, right? You need a whole project, the whole Gradle project to execute that. So this where, for example, that here comes in. So what you can do is I create a Gradle test. I specify now the Git URI of my source code, plus the branch. If I need, I also specify the type. So now Testkube knows my Gradle project more or less, okay? And if I want to let that run, it's probably taking a while, the Gradle project, but just for demo purposes, I do it anyway. Or maybe I shouldn't have watched it, but well, we keep watching here. Okay, so under the hood, what it's doing now, well, it's checking out this Git repo locally into a running pod. As you see here, oh my God, it's starting to download the Gradle wrapper. Yeah, that's, well, we wait for it. Once the Gradle wrapper has been downloaded, it will, compile it, and then, depending on which test type you specified, it will either call the test goal, or it will call the integration test goal if you have one. Same for Maven, okay? Same for Maven, you have test and integration test, and then it will trigger the right phase, and that's pretty much it, okay? So tests in the same project as your microservices. So this microservice here is a simple Spring Boot microservice. You can do the same with Maven, for example, right? Same thing here. Anyone heard of Zap? The Zap attack proxy, Z attack proxy from the OWASP project, right? Usually when you use that, it provides a nice UI. What not so many people know is that they also provide a pre-configured container that allows you to run a penetration test on your microservice endpoint. All you have to give it is an open API definition. So you say, hey, dear Zap, here's the service. Here, you can download give me a second, source main Zap. Here under the following URL, you will find the open API definition, then we will crawl that definition, and then it knows all the endpoints it can attack. And then we'll do all those standard attacks. Path traversal, request forgery, cross-site scripting, SQL injection, LDAP injection, all those bad things your service should definitely not be vulnerable to, okay? So I see here, it built, it tests, the tests ran, my Gradle tests ran. Now obviously this is all local, okay? So what if, now we go, so that you see, okay, get nodes. Now we're inside a Google cluster now, I prepared. So 5 node cluster, is it 5, 6, 5? Everything deployed here. So the gag is now, obviously, I don't want to interact with my cluster, with my integration environment using Testkube, kubectl, Testkube create test and all that. I want to be fully GitOps integrated. So I use Flux. This repo, those files here are kind of the Flux files. So you have that demo. And this is what, wait. This is, for example, what this Gradle test we just executed looks if I look at the Kubernetes manifest definition, okay? So kind test, I have a name, it lives in a namespace, and I have the content in here, the repository I just configured. So this is a plain Kubernetes manifest. I put that into my same GitOps repository. I have Flux or Argo CD watching for that repo, and then off you go. Once I change some test or add new test or delete test, Flux will take care that the cluster state contains all the tests I want. This here is, for example, what a test trigger looks like. So I say, it's a test trigger, resource deployment, namespace default, label selector, nginx. In the event of modified, I have the action of run, execute test suite, and I have this test selector here, okay? So, and the test suite is maybe the last one. This is what a simple test suite looks like. It basically has, execution steps and different, conditional logic you can insert. You have sleep, so that's pretty simple to be honest, but maybe they improve that in the future, but it gets the job done in my opinion, okay? So fully GitOps integrated in the integration environment, and using those test triggers, the right tests will run when certain things change. Thank you. Now, we've got 5 minutes left, and now I want to pitch to you the next iteration, because we're not done yet. And there's one part missing, and I talked about those 4 attributes, and that's the part of the holistic quality, right? I talked some stuff about holistic quality and this one single source of truth. When do I know my stuff is done? And that's work in progress, okay? I have not done that yet. I'm currently trying to implement a proof of concept. Now, before I show you the final solution, I don't know if you've heard of architectural fitness functions. It's kind of the term that's coined by those guys from ThoughtWorks, Neil Ford, Martin Fowler. Those 2 good books. If you want to buy a good book to read, I can only basically recommend those. And they define architectural fitness function. And think about all those quality characteristics. The reliability characteristics, the security, the maintainability, all those KPIs that are important for your system, for your microservices. And if you do the math, let's say you define, I don't know, 10 quality characteristics per microservices, and you have 50 microservices, then that's a lot of KPIs you have to have a look at constantly, because things change. Your people are working, your teams are working. So for you as an architect, you get mad, I think, if you don't automate the continuous validation of those criteria, of those performance characteristics or security characteristics. And this is what architecture fitness functions are for. To give you an idea what that might look like, think of a unit test that basically looks somewhere and gets the latest value from some time series, and then it does a simple comparison, okay? So for performance, I want that all my transactions are, complete in under 2 seconds. Then I could say, expect that K6, check transaction round trip time, is always smaller than 2. And then that's a simple unit test. You could probably express that in some Java. This is Ruby in this case. Doesn't really matter, in some unit test framework. And then let those tests run continuously, right? And those unit tests, they will fail and tell you instantly if one of your quality criteria has been failed, right? So if you failed one of your SLOs. Same for security, same for dynamic analysis, same for static analysis. I always want that test coverage is higher than 80. If someone forgets to write his unit test coverage will suddenly drop, maybe lower than 80, bing, the light is red, and I get an email or get a Slack message or whatever that tells me, hey, have a look at that service, there seems to be something dodgy. And this is then what's still missing. So on the down left-hand part, okay? So what I'm kind of looking for at the moment to explore is I want some nice quality cockpit, some fancy Grafana dashboard or something, right? Where all my quality criteria are there. And my product owner and the architect and your chief security officer could have a look at that quality cockpit and have a look at the metrics, those KPIs that are most relevant to them. All that is kind of required is some single source of truth, probably some time database. After talking to Chris Engelbert, well, I'm probably doing the POC with timescale DB, but it could be an influx DB, it could be a Prometheus, it shouldn't really matter. So all those tests that run, all those quality attributes, they should be pushed into that repository, and then I have my fitness functions run. And the ultimate goal is, and that's kind of the future, there's a super fancy tool called Captain out there. What Captain can do is Captain allows you to define your SLIs and SLOs for all your microservices. What Captain needs is a time database, and then Captain can automate the automatic promotion of your services from stage to stage to stage whenever the SLOs are met. And when they're not met, it will not promote, right? So this is then the final step towards, continuous delivery heaven. So I keep you posted on the progress. Maybe we see each other next year when I'm going to present the lower left part. Then this whole big picture is finally working. Okay, I'm super confident it will. All right, guys, that was it so far. Sorry, we don't have that much time for questions, but I'm here. I'm still here. Okay, then.
Yeah, sorry.
Okay, you said it's open source, right? So
How easy is it to get going with that without having to buy expensive consulting services from you or from other companies?
Follow the README. All you need is your laptop and a Minikube on. Clone the repo, and then you're off and going in 5 minutes. So it's really easy, okay? And you don't have to pay anyone any money. Not me, nor the Testkube guys.
Got it.
Oh my. Oh, okay. Sorry. I have like a million questions.
Just one.
Okay. Okay. On like, I guess developer experience. I'm assuming you've implemented this and using it. Yes. Cool. So it's lots of like integrated tests of like performance testing and that sort of stuff. I'm trying very hard to get people to stop doing integrated testing and get people shifting things left and doing that, but there are still some things that require integrated testing, like performance and security. How have you prevented developers from abusing the Testkube system to continue to do integrated testing when they probably shouldn't be?
Well, the good thing is I didn't have to prevent anything, but maybe that was coincidence, right? I think it's rather the other way around. I mean, there should be awareness that you definitely need those tests, right? How was it the years before? You postponed those higher level tests, which we all knew we always wanted. But due to time pressure and those good old excuses we always have, like, yeah, we do it next day, yeah, we do it before the release. And then obviously before the release, we don't have any time anymore, well, we try it. Yeah, we go to production. It was more like changing that mindset that now it's super easy. It doesn't cost you anything to let those tests run continuously whenever something changes. And so I think it was rather the other way around. And obviously, yes, there needs to be an awareness that these tests are costly in resources or time, so that you should be really sure that those tests are worth it, the integration tests.
All right, last one.
Is there a way to assess code coverage coming from those integration tests that you're running with the Testkube?
I guess there is a way, but I don't know if you should use integration tests for coverage. I doubt that you should use integration tests for that. I mean, the big problem now is, and that has always been the problem, right? I mean, the tests run, the coverage will rather be produced inside the pod of your microservice, right? So is there a way? Well, you would need some way of instrumenting using some agent, some JVM agent probably, that kind of records the coverage of those tests, and then you need to find some way to kind of push this coverage data, I don't know, somewhere, probably into Sonar, so that you then have like the aggregated coverage from unit tests plus integration tests. I've seen people doing this, but I think with the infrastructure complexity, this gets a lot harder because you need to get the coverage data out of the cluster again into Sonar. But I wouldn't say it's not possible, but I would rather question if that is really worth the effort. Yeah. Yeah. I know exactly what you mean, but in monolithic systems, I mean, if you talk about real integration tests, like your application is running in some monolithic glassfish system, then that wouldn't have been possible either anymore, or not so easy anymore. In all fairness, I think aim for, 80% coverage for your unit tests, and the rest of the 20% is not worth to achieve anyway, or very hard to achieve because it's a lot of effort, right? So as I said, for integration, I would not go for coverage that much anymore. I would more go for, do all my use cases work? I think you test something different with integration tests. You're not concerned with coverage anymore. You're more about functional suitability. Are my use cases working properly? Do I integrate with all my neighboring system? Do I connect with my database properly? I think you're testing something different, and coverage is not of your concern anymore for integration tests.
That is all we have time for.
Thank you.